Welcome to the 11th part of VCAA Specialist Maths 2021 exam papers. In this video, we will present exam paper 2, section B, question 4, which consists of 5 parts. Most students did well in part A. However, some students used the Pythagorean identity and eliminated the angle theta, which was an unproductive approach. Incorrect approaches using vector calculus were frequently seen in Part B. In Part C, most students did not provide a response in this question. Very few students were able to use the information given to state the two correct equations. In Part D, some students inappropriately used a constant acceleration formula. Very few students addressed the question in Part E and provide the correct answer.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Maths exam paper series. This is section B of 2021 exam 2 paper. There are total 6 extended response questions in section B. In this video, we will present the fourth extended response question, which states that a car performs stunt moves along a track as shown in the diagram below. The car accelerates from rest at point A, is launched into the air by the ramp BO and lands on a second section of track at or beyond point C. This second section of track is inclined at 10 degrees to the horizontal. Due to the tailwind, the effect of air resistance is negligible. Point O is taken as the origin of a Cartesian coordinate system, and all displacements are measured in meters. Point C has the coordinates 16, 4. At point O, the speed of the car is u meters per second, and it takes off at an angle of theta to the horizontal direction. After the car passes point O, it follows a trajectory where the position of the car's rear wheel relative to point O at time t seconds after passing point O is given by vector r equals ut cosine theta I plus ut sine theta minus g t squared over 2 or in parentheses j until the car lands on the second section of track that starts at point C. There are 5 parts in this question, and part A is to show that the path of the rear wheel of the car while in the air is given in Cartesian form by y equals x tangent theta minus 4.9 x squared over the product of u squared and the square of cosine theta. In part B, theta equals 30 degrees. The question is to find the minimum speed that the car must reach at point O for the rear wheel of the car to land on the second section of track at or beyond point C. In part C, the ramp BO is constructed so that the angle theta can be varied. For what values of theta and u will pass the rear wheel of the car join up smoothly with the beginning of the section of track at point C. Give your answer for theta in nearest degrees and give your answer for u in meters per second. Now the car accelerates from rest along the horizontal section of track AB, where its acceleration a meters per second squared after it has traveled s meters from point A is given by a equals 60 over v, where v is its speed at s meters. In such circumstance, part D is to show that v in terms of s is given by v equals 180 s or in parentheses to the 1/3. In part E, after the car leaves point A, it accelerates to reach a speed of 20 meters per second at point B. However, if the stunt is called off, the car immediately brakes and reduces its speed at a rate of 9 meters per second squared. It is only safe to call off the stunt if the car can come to rest at or before point B. Point W is the furthest point along the section AB at which the stunt can be called off. The question is how far the point W is from point B. Now let's come back and start to answer part A of this long question. Since the given position vector r equals ut cosine theta I plus ut sine theta minus gt squared over 2, or in parentheses j, the I component variable x equals ut cosine theta, which gives t equals x over the product of u and cosine theta. Meanwhile, the j component variable y equals ut sine theta minus gt squared over 2, in which t can be substituted and then simplified to x tangent theta minus 4.9x squared over the product of u squared and the square of cosine theta as required in the question. In part B, the question is to find the minimum speed that the car must reach at point O for the rear wheel to land on the second section of track at or beyond point C when theta equals 30 degrees. According to the expression of J component from part A, when theta equals 30 degrees, the minimum speed required for the rear wheel of the car landing on point C satisfy the equation y equals 16 times tangent 30 degrees minus 4.9x squared over the product of u squared and square of cosine 30 degrees, which equals 4, where u is the required minimum speed and 4 is the y-coordinate at point C. After substituting the values of tangent 30 degrees and cosine 30 degrees into the equation, u squared can be made as the subject of the equation, which equals 1.9 times 16 squared over the result of 4 square root 3 minus 3. Hence, u equals 16 times square root of 4.9 over the result of 4 square root 3 minus 3, which is approximately equal to 17.87 meters per second. In part C, the question is for what values of theta and u will the paths of the rear wheels of the car join up smoothly with the beginning of the section of track at point C. To land smoothly on point C, the landing angle of deviation must equal to the inclined angle of the second section of track, which is 10 degrees to the horizontal. According to part A, we have already established the Cartesian equation y equals x tangent theta minus 4.9x squared over the product of u squared and the square of cosine theta. Then we differentiate y with respect to x, which gives dy by dx equals tangent theta minus 9.8x over the product of u squared and the square of cosine theta, which equals negative tangent 10 degrees. Hence, we have two simultaneous equations, 16 times tangent theta minus 4.9 times 16 squared over the product of u squared and square of cosine theta equals 4. Tangent theta minus 9.8 times 16 over the product of u squared and square of cosine theta equals negative tangent 10 degrees. With the help of CAS graphic calculator, we solve the above equations and obtain u equals 16.4 meters per second and theta equals 33.8 degrees approximately. In order to show that v equals 180 s or in parentheses to the 1/3 in part D, we start from the acceleration a equals du by dt equals u times du by dx equals 60 over u. Hence, we have the equation. The integral from 0 to v of u squared with respect to u equals the integral from 0 to s of 60 with respect to x. After integration, the equation becomes 1/3 times v cubed equals 60s, which gives v equals 180s, or in parentheses to the 1/3. Let's refresh the criteria in part E, as this is a long question. After the car leaves point A, it accelerates to reach a speed of 20 meters per second at point B. However, if the stunt is called off, the car immediately brakes and reduces its speed at a rate of 9 meters per second squared. It is only safe to call off the stunt if the car can come to rest at or before point B. Point W is the furthest point along the section AB at which the stunt can be called off. The question here is how far the point W is from point B. Now, based on the relation being proved in part D, V equals 180s, or in parentheses to the 1/3, which gives S equals V cubed over 180, which equals 400 over 9 meters. Here we assume D sub AB equals S, D sub AW equals X, and V sub W equals U. Since X equals U cubed over 180, and S minus X equals U squared over 18, S equals X plus U squared over 18, which equals U cubed over 180 plus U squared over 18 equals 400 over 9. At this stage, we have a cubic equation where the speed at W denoted by U is a variable yet to be determined. Hence, the problem becomes to solve the cubic equation U cubed plus 10U squared minus 20 cubed equals 0. With the help of CAS graphic calculator, we solved the equation and obtained that U equals 17.162 meters per second, X equals 28.082 meters, and D sub W equals 400 over 9 minus 28.082, which approximately equals 16.4 meters. Here we present an alternative approach for part E of this question. First, we assume the distance from point A towards B is x, as it can be seen from the diagram. Since the acceleration A equals dv by dt, which equals dv by dx times dx by dt, which equals v times dv by dx, which equals negative 9. Hence, v squared over 2 equals negative 9x plus c1, which gives v equals square root of the result of c minus 18x, where c is a constant. Since v of 400 over 9 equals square root of the result of c minus 18 times 400 over 9 equals 0, which gives c equals 800. v of x equals square root of the result 800 minus 18x. Since we have already known that v of x equals 180 times s, or in parentheses to the 1/3, which can be equated to square root of the result of 800 minus 18x. Solving the equation 180s, or in parentheses to the 1/3, equals square root of the result of 800 minus 18x, we obtained that x approximately equals 28.082. Hence, d sub wb equals 400 over 9 minus 28.082, which is approximately equal to 16.4 meters.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.